Hey guys, let's discuss new problem from binary tree, which is called boundary traversal. Okay, so you have to traverse boundary. So for example, let's say you have a binary tree something like this: 1, 2, 3, 4, 5, 6, and let's say 7. Okay, so now if I ask you to traverse it boundary wise, okay, so for example, first one means root node will get printed. Okay, one will get printed, then left subtree will get printed, but you need to remember that you should not print the leaf node. Okay, so root is already done, so no need to print it double. So what you will print 2 and 4, because 5 is leaf tree, right? Now third step is you will print leaf nodes, so now 5 will consider there. So 5 is leaf node, 6 is leaf node, and 7 is leaf node. Okay, then after that you have to print right subtree. Again you have to keep in mind that leaf node and root should not get printed again. So what will get printed here? 3. So this one will be your level order traversal. So 4 steps. Okay, only 4 steps. What? The first one is root node, you will print the root node. Second is left subtree. Okay, third one is leaf nodes, and then fourth one is right subtree. That's it. Okay, then how you will do it? Very simple, very simple. Just think what you want and print those things. Okay, so if you see here in the question, so this is the boundary traversal code here. Okay, it is taking root as an input, and then it is taking one result, list of integer type of result. Obviously you have to keep a node there, right? First root, and then left, and then for one for boundary, and then for right. So list of integers you have taken there. If root equal to null, then result, then return result. Okay, this one will be your base condition. Now first it is done for the root node. Okay, so you need to check if root node is not leaf node, because means it is just only, let's say you have only one node in the tree. Okay, so in that case, if root node is not leaf node, then just add that into the result. So this is your result. Okay, what you have in result right now, let's say your tree is something like this: 1, 2, 3, 4, 5, 6, and 7. Okay, so first this one is done, one is done. Now what I said you, like second is you have to run this function for left boundary, then for leaves node, and then for right boundary, and then you will return the result. Now let's see what is happening in each function, but before that just see what is this isLeaf function, what we have used here as well, right? So isLeaf, see, when you say a node is leaf node, when it's left and right is null. Okay, left and right child is null, that time it will be a leaf node. So node.left is equal to null, or node.right is equal to null. Okay, then after that, what is happening in left boundary? See, left boundary is very simple. This one is your root node, no? And you don't need to print root again. So see, current equal to, you point current equal to root ka left initially. Okay, so current will not print root, never. Okay, never ever. So current equal to root ka left. So you start your node from here and put it into the result until it is not leaf node. Okay, and once current ka left is equal to null, right? So what you will do, you go to right subtree and then again start from left. How you will do that? See, current equal to root ka left. Okay, and then current is not equal to null. Then if it is not leaf node, then you add that into the result. So right now 2 will, first 1 get added into the result as a root node, and then now 2 will get added as a root node. Now again, current ka left is not equal to null. Yeah, it is not equal to null, it is 4. So again, what current equal to current ka left. So now current will point to this. Okay, again this while loop, again back to while condition, current is not null, so you will print this 4. Again current equal to current ka left, so current will become the 6. So you will print 6 here. Okay, let's say if you have something like 7 here, so in that case current ka left is null, so now current equal to current ka right, and then after that if you have 8 here, so then current equal to current ka left, then you will print 7 and 8. But right now we don't have that, so let's remove that. Okay, okay, now it's time to, so left boundary is done. Now it's time to add leaves. So how you will add leaves? Again you will start from starting. Okay, you will give root node here, and if it is leaf node, then only add. Okay, so you check from here, you will check from starting, and then here it will find that it will find the 6 as a root node, leaf node. Okay, so this one will not get printed as part of left subtree. Okay, now it will get printed. That I was showing you example, that's why I have added here. So now 6 will get printed, then 5 will get printed, then after that 7 will get printed. Okay, now it's time for right subtree, and right you just remember it, you have to print it from bottom to up, means first 3 will get printed, and then means from bottom to up it should go here. Okay, if there is one more node, then 7 and 3 will get printed. 5 will be part of a leaf node, right? And 1 you cannot print as a root, so you don't need to print 3 7, you have to print 7 3. For that, what you will use, you will use one stack. Okay, you will use one stack, and then you will again start from this root node, and now instead of going to current equal to current left, you will traverse it current equal to current right. Okay, so current right will come. 3 not equal to null, so 3 you will put in a root node, and it is not leaf node also. And then 7, so 7 again, but then 5 is leaf node, so leave it. Now what you will do after, once it is done, once it is done, you put this stack, okay, you pop the value from this stack and put it into the result. So first 7 will go, 7 will come, so 7 will get printed here, and then 3 will get printed here. Okay, this 5 was not there, so just don't get confused with this 5. Okay, otherwise you will think how 7 came there. So this is something like this. Till here it is leaf node, this is right, this is right, this is leaf nodes. Okay, and this is your this one, and this one is your left, and this one is your root, part of a root. Okay, so this is what happening in right subtree, right boundary. What you are doing, current equal to current ka right, and you are taking one temp list of integer. Either take a it's okay, you have taken current list of integer. Okay, current is not equal to null, so if it is not leaf, then you are adding it into the temp. I took stack, he has taken array list, so that's okay. And then current ka right is not equal to null, so current equal to current ka right. So in left it was left here, and then right was here, but here first right and then left. Okay, after that you just traverse the temp array and then add that into the result. But how you're traversing, from temp dot size -1 from back side. Okay, you're from last index you're traversing it, and that's it. So thank you.